Determine the percent composition for C6H12O6. To determine percent composition, I need to first find the molar mass for that compound. So I'll list everybody that's present inside of the compound. Then I'll reference the subscripts to determine how many of each I have. Carbon, I have 6. Hydrogen, I have 12. And oxygen, I have 6. Then I will reference the periodic table to determine the molar mass. Carbon's molar mass is 12.011. Hydrogen's molar mass is 1.008. And oxygen's molar mass is 15.999. .011 times 6 gives me 72.066. Hydrogen, I have 12 times 1.008. That gets me to 12.096. And then oxygen, I have 6 times 15.999, which gets me to 95.994. When I add all of those up, I get 180.156 grams per mole. To find the percent composition, I need to do part over whole. So for percent carbon, I will have 72.066 divided by the 180.156 times 100. Rounded to decimal places, so that's 40.00% carbon. For percent hydrogen, we have 12.096 divided by total mass of 180.156 times 100. Rounded to 2 decimal places, I have 6.71%. And then for oxygen, I will have the 95.994 divided by the total 180.156 times 100. Rounded to 2 decimal places, I have 53.28%. Arrange the steps of making the empirical formula in order. So these are 4 options for our steps. We have mass to mole, divide by small, multiply till whole, and percent to mass. This is going to be in kind of a limerick rhyming scheme. And that rhyming scheme goes percent to mass, so this is number 1. Mass to mole, that's number 2. Divide by small is number 3. Multiply till whole is number 4. So all together it goes percent to mass, mass to mole. Divide by small, multiply till whole. The empirical formula is the blank formula, whereas the molecular formula is the blank formula. What I'm looking for here for empirical formula is going to be the simplified formula, whereas the molecular formula is going to be my true or correct formula. A compound is found to contain 50.05% sulfur and 49.95% oxygen by weight. What is the empirical formula? So first thing I'm going to do is I'm going to change my percents to mass. So I'm going to have for sulfur and for oxygen, I'm going to have 50.05 grams and 49.95 grams for oxygen. Then I will do mass to mole, and I'll do this by dividing by the molar mass from the periodic table for each. So sulfur's mass on the periodic table is 32.066. Oxygen's mass from the periodic table is 15.999. You're going to want to keep as many decimal places as possible to limit errors from rounding. Okay. Next step is to divide by small. This number is smaller than this one, so that's what I'm going to divide by. I'm going to divide both by the 1.560843261. Anything divided by itself will be 1. Okay, so 3 blah, 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 divided by the 1.56 gives me, this is close enough to 2. These are already whole numbers, so I don't need to multiply until they're whole. I can just go ahead and assign them as these subscripts. The molecular weight for a compound in the previous problem is 64.07. What is the molecular formula? So to find this, I need to find the molar mass of this empirical formula first. So I'm going to go ahead and I'm going to list out my components. I have sulfur and I have oxygen. I have 1 sulfur. Sulfur's mass from the periodic table is 32.066. 1 times anything is that thing. Oxygen's mass from the periodic table will be multiplied by 2 since I have a subscript of 2, and its mass is 15.999. Two times 15.999 gives me 31.998. When I add those two up, I am left with 64.064. When I divide, we're going to have the molecular formula's mass on top and the empirical on the bottom. When I divide the molecular formula's mass of 64.07 by 64.064, I'm going to get a number that is close enough to 1. So that means I would multiply my subscripts by 1. So my final formula for my molecular formula as well is going to be the same as my empirical, and it will be SO2.